And next, I want to cover broadly how Tintri has approached this subject of intelligent infrastructure. And so fundamentally what we mean is storage infrastructure solutions that use telemetry to self-optimize. And I'll talk about these things at a high level, and then we're going to lead into a demo. Again, the early part of this presentation is really about covering like a recap of all the things that we've already brought to market and that serve as kind of our North Star for all of the other developments that we plan on making in the future. I want to address the topic of intelligent infrastructure. So what you see on the screen, I've removed the brands just because it's not about particular vendors. It's about the language that we're beginning to see in the industry to help kind of drive differentiation. I think the point is that we're acknowledging that for our customers, we are cresting this point in the IT infrastructure world where we need more intelligence, we need more autonomy. I think as we acknowledge the benefits of the concepts like AI ops, that's a nod and a wink to a problem, and that problem is that our infrastructure that we deploy is supporting these really dynamic environments. These dynamic environments often exhibit behaviors that are hard to tease out and to get insightful, actionable data from, and that we're asking, or we're hoping that AI is going to help solve these problems. And so here we've got a number of examples. You can see kind of what the keyword, industry buzzwords are: autonomous, intelligent, artificial intelligence. These are really important things, I think, for the next generation of infrastructure systems. Storage, I think, is probably the one that could stand to use these advancements the most. But whereas maybe a decade ago you saw things like flash and speed and speeds and feeds, these are much more nuanced capabilities that I think are important to capture and qualify in a meaningful way to again extend this value to our customers. So I'm going to go off a little bit on a tangent and describe a situation that these types of kind of seismic shifts, these generational shifts in technology, they don't just happen in IT infrastructure. They happen all over the world and in different markets. And the most recent one that we've experienced is in autonomous driving. And what I have on the screen here are two pictures that look relatively similar. They're inferring that you've got a vehicle, the vehicle's got sensors, but they result in different things. In one case, we've got something lane assist, a feature that we're very familiar with. And on the other side, we have self-driving. Both of these features are considered under the umbrella of autonomous driving. And they exist within a continuum or a pantheon of features and functions. But it's hard, if you look at it like this in this weird context, to determine which one is more valuable, which one is less valuable, which one requires more human intervention, what requires less human intervention. And so a number of years ago, SAE helped us kind of define that, right? So the Society of Automotive Engineers developed this matrix for how to look at features as they pertain to autonomous driving. And you can see that we start with level 0 and we end at level 5. And as you march towards the right-hand side, the onus for a lot of the functions lie on the vehicle itself and less on the human being that's sitting in what we would historically refer to as driver, or we still refer to as driver's seat. At some point, that seat, whatever country you're in, that might not be called the driver's seat in the future. Well, at Tintri and at DDN, we aim to do the same thing. And so as the market shifts to understanding these terms like AI, intelligence, et cetera, we want to provide a framework for our customers and for the market at large to understand, as we bring these features to market, where do they live and where do they live on this continuum towards essentially what we're calling autonomous or self-driving storage. And so here you can see our level 0, focusing on the lower left-hand corner of this matrix. It's really basic stuff that we've seen before: threshold-based warnings. Those can happen at the appliance level. They can happen in the cloud, etc. Level 1, you start to get predictive alerts. So this is the ability at a very low level to understand trends from the data that you're collecting and to infer whether or not there's going to be a problem in the future. And then as we get to level 2, 3, 4, things get more robust, they get more sophisticated. And you can see that there's a very clear demarcation point between level 2 and level 3. And this is our view of the world. And that demarcation point is when human beings have much less responsibility from an operational standpoint in managing the storage. It means that the system itself is able to gather enough telemetry, it's instrumented in the right way in order to solve some of these day-to-day problems that are afflicting our customers in the market. So with that, I want to kind of switch modes here. And we want to talk about artificial intelligence. We want to talk about it just kind of bluntly. At Tintri, since our inception, we have taken this view that the automated analysis of telemetry and the automated optimization based on those telemetry is valuable, and that we take action on these things at 3 different levels. We apply AI at 3 different levels. I know that the normal thing to do is to kind of start at the top and work your way down. I'm actually going to do it backwards. We're going to start at the low level, kind of focusing on the technologies that we've brought to market already that have made the majority of our portfolio over the last decade with the appliance and then the control plane. So at the appliance level, what we've done, and I'll show you via a diagram and then later through a demo, is we've built an intelligent storage system that is instrumented in all the granular ways to understand these fine units of measurement. And in our case, when we started, it was VMs. VMs and the collection of VMs on storage systems were hard to manage for. They're hard to predict. And so, taking a first principles view of that problem, we were like, is the traditional storage constructs like LUNs or volumes, are those the right ways to address these highly dynamic environments that change, where the in-guest behavior has all these compounding effects on the storage? And at the time, and we still believe this, that we decided we wanted to go with something that's a lot finer grained than just LUNs or volumes. And so we've invented this concept of managed object level management. And managed objects is an internal, it's a Tintri term, but it refers to things that are not traditional storage constructs. So a managed object in our ecosystem could be a VM, could be a database, as we'll show you later, it could be a container volume, it could be anything that is valuable to our customers. Our first and probably biggest innovation to the market is our ability to measure those individual units of measurement, those VMs, those and now databases and container volumes, to analyze their workload behaviors in real time, and then to basically reconfigure the array dozens of times per hour so that every single one of those managed objects gets sub-millisecond latency. On the right-hand side, you've got some boxes, and those are some key data points. At the appliance level, we're doing a 10-second sample of about 56 data points per managed object. And again, the goal is to make sure that the array can service those I/O behaviors at that right granularity at sub-millisecond latency. Second, just above that,
Erwin,
yeah, please.
Is that analysis done at the appliance, or is it done in the cloud, or
it's done on the appliance?
Oh, okay.
Yeah. And I'll talk about why that's so important and why that's so differentiated for us, but that's a really excellent question.
Okay, thanks.
Yeah. Second is this layer above it. It's the control plane. So for those of you that are familiar with the Tintri VMstore, and maybe even for those that are not, VMstore is a self-contained dual controller storage array in a 2U footprint. And to expand them, we do not add shelves. We do not, we federate multiple appliances together. And then we federate them using our control plane called Tintri Global Center. It's installed on-prem. And we treat the entire ecosystem much like vSphere treats ESX hosts, or vCenter Server treats ESX hosts. And it's to federate them together, loosely couple them together, to collect telemetry from each of them, and then to analyze whether or not the workloads that exist on those appliances are optimized in a right way. We'll talk about that and what that means a little bit later. At that layer, we're doing a 10-minute sample of all of the VMstore appliances. We stack all of those samples together to create a 30-day history. And we do some pretty sophisticated Monte Carlo simulations to project whether or not there's going to be a condition that would threaten the happiness of all of the VM stores and the managed objects they serve over the next 7 days. And then we make these prescriptive recommendations about how to resolve that every 12 hours. So I'll stop there. We won't talk about cloud until a little bit later. But let's talk about what happens on the VMstore within the appliance. So this is a rough kind of architecture of what we do at the appliance level. So at the very top, you see a little box that says ecosystem managers. This is really important. This is how we gain context for the files that live on our file system. And then the big box at the bottom is VMstore, VMstore OS. And so you'll notice that there are kind of three key areas where we have instrumented the appliance sufficient to kind of gain some knowledge about what's happening on the storage array. At the very top is a component we call protocol manager. And what it does a lot of different things, but primarily within the realm of kind of AI and self-analysis, is it integrates with the ecosystem. So you can see there's a little red arrow here. And we create these integrations so that as the files land on the file system, VMstore knows who to ask to give it contextual awareness of what those files are. So on the left-hand side of that box at the very top, you'll see that we integrate with the hypervisor manager. This is all very important and very native to what we do. And we'll ask vCenter server, hey, we've seen a lot of files on this data store. What are those files? Tell us what they mean. And we do that for multiple hypervisors over multiple protocols. So you can see we support VMware, Citrix Hypervisor, Red Hat Enterprise Virtualization, and Hyper-V. And this is our bread and butter. This is what we started with, and that's what we've brought to market over the last decade. Focusing back on VMstore OS, you'll see that the next layer down below the protocol manager is the resource performance manager. This is where we're analyzing the I/O patterns of every single one of those individual VMs and vDisks. And we have a very sophisticated method for understanding not only what the behavior means, but what the appliance has to do from a resource optimization standpoint to ensure that that workload behavior gets sub-millisecond latency. And we do that autonomously. There's no configuration. There's no setting policies. You literally turn on the box, and this is what it's engineered to do. And for our customers that have highly virtualized environments, which at this point I think is most of them, it means that you can have really large data stores without having to configure them to do specific things. That the VMstore will just provide the storage to the hypervisor. You can put any VM doing any in-guest operating system, doing any in-guest application, doing any in-guest behavior, and VMstore will see it, analyze it, and then respond accordingly. And then all those things are integrated, again, as part of the operating system and integrated deeply with the proprietary file system that we've developed. And so it means things like working set analyzer, which is a very, it was originally developed for our hybrid arrays. It was meant to give us an understanding of how much data within a total VM's footprint needed to be accelerated by flash. We still have that, and it's very important that we have that, and we'll show you how we use some of that information potentially in the cloud. And then all the other data management features that you would normally associate with a storage array happen at that right granularity. So snapshots happen per VM at the array, very fast, stunless, very efficient, cloning, instantaneous, again, per VM, replication, same thing, encryption, synchronization, our ability to kind of peel open the contents of a virtual machine and maybe take data from the secondary volume of one and put it into the secondary volume of another on the fly. These are all very important things that we've developed over the last decade that we've brought to our customers. And again, leverage all of these things, this instrumentation, this AI that we've embedded into the array to do these things. And then the UI elements on the right-hand side, I think is very important for us to kind of talk to. So in our world, the UI represents a product of the AI, meaning that the UI isn't for the end user to figure out how to tune the array. The UI is meant to show you what the array has already done for you. And that's a very different value proposition. When you say VM aware, which is I think is a very common descriptor for storage technologies today, everything is VM aware. They've got a plugin that integrates with vCenter. It can show you what VMs live on what LUNs. When you shift that focus and you say, well, what did the array do, knowing that it has VMs on it, and the answer is nothing, that Tintri and VMstore is a very different value proposition for our customers. Okay, let's quickly transition to what we do at the federation level, so at the control plane level. So every VMstore is managed by a virtual appliance that can live on the VMstore itself. And it runs a number of different functions. But what I want to focus on today is how we use a telemetry from every single one of the individual appliances. And we analyze an entire pool of appliances holistically to determine whether or not the relationship between the individual VMs and the appliances they live on is optimized in some kind of way. So on the left-hand side, I guess I should stop. I'll pause here. I'll go back to the bottom of this slide. So what you see at the very bottom are these dark boxes that I call VMstore appliances. These VMstore appliances, each Tintri Global Center virtual appliance can manage up to 64 of these physical appliances. These physical appliances can be heterogeneous. They can be anything from our first generation product that you can't buy support for, but maybe you want to use it because it's awesome, or you've got some nostalgia for it, all the way to our latest generation systems later this year, introducing the NVMe-based appliances. Now that heterogeneous nature of these pools means that there are different calculations that have to happen based on what VMs live on what appliances. The way that a VM behaves and interacts with a hybrid array fundamentally is different than how it would interact with an all-flash array or even an NVMe array. And that the point of Tintri Global Center is to understand those relationships and determine whether or not the workload behavior that we see from VMs is best suited for the appliances that they sit on. And so you can see here, we've got a number of pools. In this case, this is the concept of creating that federated cluster. You can have up to 32 of them. So if you have 64 appliances, you can have 32 two-appliance federated clusters. And all of those VMstore appliances are shipping their data every 10 minutes to Tintri Global Center. So Tintri Global Center can, again, create that 30-day history from which it draws these simulations and makes these predictions. So now focusing on the Tintri Global Center box. So it's important that we acknowledge that in order to make really good future decisions, you have to have a really long history of historical decisions. And at Tintri, with Tintri Global Center, we decided that 30 days is kind of that nice middle ground for, again, being able to predict something within the next 7 days. We look at things like appliance telemetry, which is, we'll go through it in the middle here, as well as the individual managed object telemetry. So I described earlier, and I'll say it again, managed object is a Tintri term, and it means the units of measurement that are finer grained than traditional storage constructs. So in our world, that means VMs, databases, containers, etc. Twice a day, the system will run a series of Monte Carlo simulations that take a bunch of different inputs, make a prediction about whether or not any of those inputs and the trends associated with those inputs would indicate a problem with the holistic status of the pool. It could be something like, some of them are going to run out of capacity. Some of them are going to have a problem guaranteeing the sub-millisecond latency that we've imposed on all the VMstore systems. It could be something like, hey, you've got a mixed heterogeneous pool of hybrid versus all flash. And the working set, that working set analyzer I talked about in the last slide, maybe the working set would indicate that a workload that sits on a hybrid, it has a working set that's bigger than the flash cache on that hybrid. And so it can make recommendations about whether or not that should move to an all-flash array, etc. We take into consideration things like thin provisioning, whether or not there are snapshots that are based on specific VMs, and the deduplication rate of the data that sits on the arrays. And then we create what we refer to as a least cost prescription for how to migrate data across the VM stores in that pool. And then beyond that, what we introduced in the last couple of years is a fully orchestrated and offloaded migration. So I don't have a slide for this, but you can imagine that a VM that has a lot of snapshot data, maybe it's a big VM with some mixture of live data and empty space, a 2 terabyte filer VM, whatever that might be, with a bunch of snapshots. You would be right to say.
Erwin,
go ahead. Go ahead, Ray.
The difference between the prescription is going to tell some operator, this is what we think will your best solution to potential problems, and these might be the potential problems that you see in the next 7 days.
That's right.
But the fully orchestrated migration automates all that migration for you.
Yeah, that's right, and even offloads it. So it doesn't require what traditionally you would do if you didn't have an offload is you would rely on, in the case of virtualization, vMotioning, triggering a vMotion in the vCenter world to move the VM from one data store effectively to another data store. And part of the Monte Carlo simulation is to determine whether or not the VM that you want to move has snapshots. And a vCenter vMotion would not recognize that those snapshots even exist. And so we have to almost take the responsibility of moving the data between the source and the target, and then coordinate with vCenter so that vCenter believes that the storage vMotion is happening, but the actual data migration, a large chunk of it, a large percentage of it is happening between VM stores autonomously without involving the host.
Okay. And is it fully orchestrated migration available today to your field?
Yeah. Mm-hmm.
Are you seeing, so the question that I really want to ask is how often are migrations happening in a typical VMware environment or vSphere environment?
So that's an interesting question. I don't have the data with me. And if we can cover that offline, we can get that data for you.
That's fine.
Yeah. But go ahead.
Can I chime in on that one?
Oh, yeah, Rob.
That's all right. So you asked how often do they happen in a typical vSphere environment? So our model is not the typical model because we've allocated all resources to an entire piece of hardware. So on a VMstore, these data stores typically show up as hundreds of terabytes, and with hundreds, thousands of VMs in them. So our beginnings, our model is not to move VMs in the first place. So it's to leave them in place and govern resources accordingly without having to move them to fix hotspots. And that's very different than anything that depends on LUNs and volumes that leverage something like a VMFS file system that then have different LUNs and tiers associated with different characteristics for snapshot schedules, performance schedules, things like that. And when you have that model, you have many more data stores and they're much smaller. So if we were to take one VM store, that would look like one data store inside of a vSphere environment. And the equivalent on another storage system very easily could be 20 to 50 data stores for that same capacity and same number of VMs. So now we're talking about moving from completely separate hardware and migrating them. So now, each of these data stores are tens of hundreds of terabytes. So that movement on the day-to-day, we've already decreased that substantially. So we don't see customers having to move things between appliances very often, and we certainly don't try and balance it. When they do need to move, it's because there's something about those VMs that are jeopardizing others. I don't know if that kind of answers the question, but it sort of gives more context that we're not talking about the same tens, hundreds of data stores that you'd typically be working with.
And we'll go through it. Go ahead.
Oh, I just want to clarify. When you say snapshots, you mean storage snapshots, not VMware snapshots, right? Or
yeah, they're storage snapshots, but again, VM level granularity. So they're not storage array snapshots that capture more than just what you care about.